All right, anything else on your homework? Was everything else okay on your homework? Are we good to this point? All right, so on the little bit of calculus that we've started. If I give you a limit problem, with what I've taught you so far, all you can do is make a table and get a guess off of the table. Are you guaranteed that your guess is right? No. Now, what you can do is this. From this point forward, that's kind of in case for emergency break glass. In other words, what we're going to do today is we're going to learn to do it graphically. Then we're going to go do the formal mathematical definition of a limit and do some proofs. Okay. Next week, you're going to get shortcut theorems. Everybody with me? To cut down on the work, but you don't have them yet. But there's some algebraic tricks that are going to come into play when we start using those shortcut theorems. But on a test, sometimes you may get lost in the algebra. So if you get lost in the algebra, what can you always do? Make a table and what? Get a guess. Now, if the correct answer is 4, you can probably get that off the table in Jesus' left. Okay? If the correct answer is a square root of 17, you're not going to get that off the table. So you can't just make tables everywhere and do well on the test. Everybody with me? But it's always in your back pocket. You're not guaranteed your answer is right, but it's your best educated guess. And an educated guess is better than none. All right. So one of the ways that we're doing limits, all right, we're doing them basically, I think your book calls it numerically. I tend to call it tabularly, but it doesn't matter. In other words, make a what? A table. All right. The second way I want to kind of talk about it for a minute is I want to talk about graphic. Now, all right, suppose your graph looks like this. Suppose that red curve is your graph. So you no longer have the algebraic representation of your f of x. Your f of x is simply that picture. So you can't make a table because you don't have the algebraic representation. So now you're going to get me some limits from that table. Now, let's make sure we understand what I mean by this. If I say the limit of f of x as x approaches, say I do a 2. What I'm asking you is on that picture, on that graph, because we're doing it what? Graphically, as x gets closer and closer to 2, is y getting closer to anything? Now, the other thing I need to make sure you understand is the difference between these two things. Those. F at 2 and the limit of f of x as x approaches 2. What does f at 2 mean? When X is what? Exactly 2, what is your Y value? So I'm checking how many places? 1. So on that graph, when X is exactly 2, what does your Y look like it is? Looks like it's 0. Now you might say, well, I think it's crossing up there. I think it's 0.013. Okay, whatever. You know what I'm saying? Like, we're just getting an approximation. This has nothing to do with this. Nothing. They are not remotely related. All right. So the first one is saying when X is exactly 2, what is your Y exactly? This one is saying that you're getting closer and closer and closer to 2, but you never what? You never get there. So what I want to know is, as you're getting, if X is getting closer to 2, is Y getting closer to anything? Now let's make sure we understand this. If I'm getting close to 2, I can get close to 2 from the left side, or I can get close to 2 from what? The right side. What is this thing for me to do? Both. And the answers have to match. So if I get different answers, that doesn't have an answer. Now, sometimes you will see a superscript on the number. Like sometimes they'll ask you this. What's the limit of f of X is going to have X approach has got a 2 with a little negative? Now here's what that means. That means from the left side only. If you see this, the limit of f of X as X approaches 2 and there's a superscript of a plus, what do you think that means? From the right side, what? Only. Now, if you don't see any superscript, that means you've got to come from what? Both sides. And the answers have to match. So even if you're not told to do this, when you're doing one of these, you really have to do both of those. So look at your picture. All right, do we agree that that's pretty close to 2 on the left side? So I need to know what's that Y value right there. Well, now you'll see me, if I'm doing it at my desk, I tend to go over here and look. Is everybody with me? Because that's how tall it is. So what does it look like about what to you? About 0.5 or something? All right. What if I got closer? Isn't that closer to 2? Yeah. Okay. Well, what's the Y value right there? Well, again, that looks like about maybe what? All right, 0.3. All right, get closer. Get closer. What is it like your Y value is doing? Or does it look like it's getting close to anything to you? Yeah, I think it looks like it's getting close to 0. It's getting shorter and shorter and what? Shorter. Now, again, this is the guess. Am I guaranteed that I'm right? What? No. But that's a guess. But that means come from the left side only. Is everybody with me? Separate question. Now, what does it want me to do? Come from the what? The right side. All right, do we agree that that's pretty close to 2? And it's on the right side. Well, now my graph's not up here, it's what? It's down there. So now, what's the Y value right there? What would you say about maybe what? Negative 0.4, okay. What if I got closer to 2? Isn't that closer? Okay, well now, what's the Y value? Maybe a negative what? 0.2, 0.15, something. All right, isn't that closer? Again, what does it look like my Y value might be getting close to? 0. So what's this answer? 0. Okay. Then I want you to do this one for me on that picture. I want to know what's happening when you're getting close to 1. So without being told, that means you need to do the limit as you approach one from the left. Without being told, that means you do the limit as you're approaching one from the right and see what happens. So you work on that on your paper for just a second while I kind of get this erased and redrawn. All right, you help me. Does it matter which one I do first? What? All right, if I'm on the left side of one, so if I'm on the left side of one, that's pretty close, isn't it? Now, where's your red graph? It's way up here, isn't it?
Yep.
So what's the Y value right there about? What do you think?
1.6.
1.5, 1.6. Okay, get closer to one. Okay, we'll get closer. All right, now I'm up here. Yeah, when I get closer, do I see what I'm doing? What's your guess for this left hand limit? Looks like it's pretty close to 2. Could be 1.9, could be, who knows, but it looks pretty close to 2. Does everybody agree with that? All right, well, now let's go do the right hand. All right, if I want to do the right hand limit, that's pretty close to 1. So what's that Y value? Maybe 0.7 or something. All right, if I get closer, what do you think? 8. Does it look like I'm getting close to anything from that side? 1. Does everybody see that? And what's the answer to the limit of my function as I'm approaching 1?
Undefined.
Undefined. I don't care if you write undefined. I don't care if you write doesn't exist. I don't care if you write no answer. Do you see what I'm saying? There is no answer to that.
Wouldn't it be because the open circle?
No, and I'll show you why in a second. Now, answer me this. What's the answer to this first one? What's F at 1?
1.
1. Why? Because when you're right at 1, that's a hole. What does that hole mean? There's not a what? Not a point. The point's right there. And that's the point 1, 1. So when X is 1, Y is what? 1. Now, let's go back to Gabby's question. -1 and -1. So I need you to, on your paper or in your head or whatever, I need you to get close to -1 from the left side and from the what? Right side. Whether I tell you to or not, you've got to do that to do a plain limit. You've got to approach from the left side, that's called the left-hand limit. You've got to approach from the right side, that's called a what? A right-hand limit. And for this to have an answer, those answers must what? They must be equal to each other. So sometimes I'll just ask for a left-hand limit. Sometimes I'll just ask for a right-hand limit, and sometimes I will ask for both. But even if I don't ask for both, at least mentally, you have to do both. All right, do we agree that that's pretty close to a -1 on the left side? So if we come down here, our graph's about right there, that's about a -0.8, what would you say? 8. All right, if I get closer, isn't it dropping? What does it like the answer to this might be? Now, is it -1 because there's a -1 right there, or what? No, right, because that's what I'm getting close to on that y-axis. Limits are y's, right? Now, what happens when you repeat the same thing on the right side? It's also getting close to -1. Is everybody able to see that? All right, even when I'm coming on this right side, I'm getting closer and closer and closer to what? -1. So what's the answer to this? -1, because they're the same what? Answer. What's the answer to this? +1. Everybody with me? Why? Because when you're right at 0, there's a hole there, but there's a point up here. So what's the y part of that point? It is what? So do these things have to match? What? No. What if this point was missing? What if that wasn't there? If that point wasn't there, what would this answer be on number 1? What? Undefined, doesn't exist, no solutions. Everybody with me? So what I need you to understand is what happens right at the point has nothing to do with the limit. Sometimes they're the same, sometimes they're different, sometimes one exists and one what? One doesn't. Now let me ask you this. What if I ask you, what's the limit as x approaches 3 from the left side of that function? So that's pretty close, isn't it? All right, so there's about a half. That's pretty close. Ooh, now it's almost. What's happening every time to your y values? Here, here, here. Everybody with me? What's happening? It's just doing what? It's just dropping in what? Dropping in what? Dropping. Are you getting close to a single value? What? No. So the answer to that would again be, now your book sometimes will put D and E. Guess what that means? That's not what exists. It's just a lazy way. Now, later they might say this. Now I'm going to kind of give you a preview of coming attraction. That is always correct. That's a better description. Why? That tells you it doesn't exist because. So that gives you doesn't exist with a reason. Why doesn't it exist? Because the values are going down, down, what? Down. Now, what if the graph went this way on the right side? Well, again, if they do that, then it's just getting what? Bigger and bigger. And so does not exist is right. But a better explanation would be what? Positive infinity. It doesn't exist because the values are just getting what? Bigger and bigger and bigger. But if this is that way, what does that mean when there's no superscript? You got to come from what? Both sides. You don't put positive, negative, infinity. Your best answer there is simply what? Does not what? Exist. Okay. So part of your homework is going to be, I'm going to give there's going to be a picture posted on Canvas that looks sort of like that. And I'm going to ask you to go get me limits off of the picture when you don't have, when you can't make a table because you don't have the algebraic representation of the function anymore. I might ask you, is that a function? Well, how do you tell if something's a function? Vertical line test. I might ask you, is it a one-to-one function? Well, now it's got to pass the vertical test just to be the function, but it's got to pass the what? Horizontal line test about the one-to-one. You can be one-to-one and not be a function. Those are two different things. So a one-to-one function has to have both components. Okay, so are we okay then, if I give you the algebraic representation, are you okay on making a table and getting a guess? If I give you the graph, are you okay on getting a guess off of the graph? Okay. Third way. Definition. All right, so we're going to talk about the mathematical definition of a length. And then we're going to talk about proofs, and you're going to learn doing simple proof for me. Okay, they're much more complicated proofs. We're just kind of learning how to do a template of a proof. If you can't do a template, then you got no hope later. Okay, so we got to start kind of baby steps. Now, all right, that's the form that you always see. You've got the limit of some function, you've got x approaching some number, and then you get another number answer. All right, now let me show you mathematically what that means. That means that for every epsilon greater than 0, there exists a delta greater than 0, such that if the absolute value of x minus c is between 0 and delta, then that forces the absolute value of f of x minus L to be less than epsilon. I guarantee you, I'm going to ask you to state that definition on your first test. It is the basis of all calculus, is that definition. So this is only true if this is true. Okay. Now, a couple of things. When you see epsilons and deltas in math, often, not always, but often they stand for very small numbers. I mean, you can have an epsilon that's 100, but usually they're not, they're going to be small values. So it's just kind of a guideline, not a rule. Now, this is the reason that absolute value is on your algebra 3 review sheet. All right, I'm going to drop this 0 for just a second. I want you to concentrate on this one. Remember when we did those absolute values? Or something. What's your connector word when you have absolute value with less than? The connector word is and. So that means that x minus 2 has to be smaller than 8. And it means that x minus 2 has to be what? Greater than or what? Negative 8. In other words, x minus 2 has to be between what? Negative 8 and what? 8. Remember, that means and. So do you understand what this is saying? Then this is saying that x minus c has to be between what two values? Delta and what? Negative delta. All right, so what does that mean? Well, how would I finish this? How would I get rid of that minus 2? What would I have to do? Add 2 all the way across. Is everybody with me? So the same way here, if I want to get rid of this minus c, what does that mean? I got to do all the way across. Add c. We okay? Now, what's the same thing as a negative delta plus C? What's an easier way of saying that? C what? Minus delta, and that's the way they show it. So C minus delta and C what? Plus delta. So here's what we're saying. Right? I've got some basically value down here, some C. So you understand that says C plus a little bit and C what? Minus a little bit. C plus a little bit and C what? Minus a little bit. And these are the same. You're not adding 2 over here and subtracting a half over here. Everybody with me? It's the same thing. Now, so what's this gonna say? Well, this is going to say that f of x minus L is going to be between what 2 values? Epsilon and what? Negative epsilon. Right? So what's that going to say? F of x is going to be between, how am I going to get rid of that minus L? I'm going to have to do what? Add it to both sides. So I've got a negative epsilon plus L, and I've got an epsilon, positive epsilon. But there's an easier way of saying negative epsilon plus L. What's the easier way of saying that? L minus epsilon, and they're just going to call that for, for symmetry L what? Plus epsilon. So you understand what that means? That means L plus a little bit and L what? Minus a little bit. Question.
If it's a cross like that in your book, are L and C gonna be real numbers?
The short answer is yes, but it's about to get abstract anyway. All right, are we okay? Now, here's what it's basically saying. For this limit to exist and be a number, like you were saying, like if you had the limit of 2x plus 3 as x approaches 1, if you did think that's 5 because you did a table. Then here's what you're saying. What's your x going to be? Your x is going to be what? 1. What's your L going to be? Your L is what? 5. This says for every epsilon imaginable. So you say epsilon is 1, okay? That means I'd take my 5 and what? Add what? Or so I'd be up to a what? 6 and down to a what? 4. I've got to come up with some C value around 1. So that if you're in this interval, the graph stays in the box. Because I'm saying, you tell me epsilon, then I've got to figure out the delta so that the y value is between here and where? Here. If I can't do that for every epsilon that you can come up with, the limit blows up. There's not a limit. If I give you an epsilon and you can't come up with some interval around here that graph stays in that box, that means the limit doesn't exist. And it can't just work one time, it's got to work what? Every time. Because there may be, remember that jump we had in the graph a minute ago? Are you ever going to have a limit at a jump? No. Why? Because when you're coming from the left side, that's always going to be different than when you're coming from the what? Right side. So what happens is sometimes when you got a really wide range, I can stay in the box. But when it starts shrinking, there's going to be some point where the what? The graph goes out of that what? Out of that box. Now, can you have limits when there's just a hole? Yes, and here's why. You see this says 0 is less than that number? When's the only time this absolute value is going to equal 0? When X is the same thing as what? C. Do you ever get to that number? So that's why you can have limits at home, because no matter how much you shrink that box, there's still some wiggle room around that hole, and you're always in the box. If that's a solid point, you're good all the time. If there's an asymptote, at some point, you're going to go outside that what again? That box. Now, let's talk about this. All right, so suppose I did do this to you. Suppose, let's see. Let's do this. All right. So for homework, so to speak, what I'm going to ask you to do is this. It's going to be a linear function because we got to start somewhere. Okay. You're going to get me a guess for the answer. Now, where can you get the guess from? A table, or now even a what? A graph. You get to pick. So once you get your guess, then I'm going to tell you to use the definition and prove to me that your guess is right. Now, what I'm about to do first is I'm about to do something with numbers. Then I'm going to go generalize it and make it more abstract. Now, here's what's strange about the definition. Who gets to pick first? Epsilon or delta? It says for every what? Epsilon. Okay. Now, let me confess. So I'm supposed to start with the epsilon part and go to the what? In other words, it says for every epsilon, it says this. Now, let me show you this, all right? You read it out for me, and I'm going to write it in mathematical notation because I'm lazy. What's the definition say? Read the exactly what I wrote. What does it say?
For every epsilon.
For every what? Epsilon greater than 0. What? Such that is shorthand mathematics notation. So when you go to Cal 2 and I or somebody else throws that on the board and you think, I have no idea. In math, that stands for every. That's an epsilon. That backwards capital E is a such that, I mean, it's a very exist, and that's a such that. All right. So you're like, what now? Here's the real reason. I mean, it's really because, for instance, if I pick up an article in a German journal, I don't read a lot of German. I know this much German. Are you with me? But those symbols are universal. Math has its own language, and that's one of the reasons it has its own language. I can read it no matter what language it's in. Is everybody with me? All right. So here's what it says. If what? The absolute value of x minus c is less than what? Delta what? Then the absolute value of f of x minus L is less than what? epsilon. So here's what they're telling me. They're telling me I've got to start with this and end with what? That. Everybody good? Now, here's my confession. When I was in high school, I was pretty good at math. So I would be in, say, my physics class, and he was in his class. So I would just mathematically compute what I was supposed to get. And then magically, my data fit that. Now, is that what he wanted me to do? What? No, but he didn't find a way to prevent me from doing it. You see what I'm saying? Like, I wasn't advertising, that's what with enough error so that it's believable. You see what I'm saying? So I was supposed to start here and what? In there. But what did I do? I did that and then worked what? Backwards. Now, when I presented it to him though, what did I start with? What he told me to, and then what? That's what we're gonna do. So rather than starting with this and ending with this, guess what I'm about to do? I'm gonna do some scratch work so I look brilliant in a second. And I'm gonna start with this and what? Get to that. Now, help me out here. What's my f of x in that problem? 2x what? Plus 1. All right, minus, what's my L? 7 is less than what? Now, you say, my what? My what? Epsilon. Now, here's the catch though. Epsilon can be anything, correct? And for every one somebody gives me, I've got to find a delta, all right? Then you give me an epsilon. It's supposed to be a small, give me a small, you know, one sounds great. All right. Epsilon is 1. So what am I going to put right here? A 1. All right, let's solve this puppy. All right, so what does this mean? Well, first of all, can I simplify the inside? So that's 2x plus what? I mean, 2x minus what? 6 is less than 1. So what does that mean? What's 2x minus 6 going to be between? -1 and what? 1. Does everybody see why? That's why the absolute value is on the review sheet. I need to solve for x. So what do I got to get rid of first? The -6. Right? How do I do that? If I add it in one place, I got to add it what? Every place. So what's 2x going to be between now? What's a -1 plus the 6? And then 1 plus the 6 is a good. So now how do I get rid of the 2? Divide it. So what's x going to be between? 5 halves. What's that? 2 1/2. And what? 7 halves, which is what? Now, we agree. Now watch. Here's x, right? What does this mean? This means that x minus, what's my c over there? 3 has to be less than delta, correct? So what does that mean? That what or at a what? Negative delta? So what does that mean? X has got to be between. What do I do with that -3? Add it. So that's going to be a negative delta plus 3 and a delta plus what? 3. What's an easier way of saying negative delta plus 3? 3 minus delta and what? Apparently, what do I need delta to be? 0.5. Why? Because 3 plus what is 3.5? 3 plus what? 0.5. And by the way, even 3 minus 0.5, it's got to work both places, right? So you say epsilon's 1. What am I going to say delta is? Now, are you going to show me all of this fraction? Am I going to show you all of this? No. What am I going to do? I'm going to say, I'm going to like, this isn't even showing anywhere. Is everybody with me? I'm going to go, oh my goodness. I'm going to delta 0.5. And I'm going to start with what? This. X minus what? 3 is less than what? 0.5. So what does that mean? Well, that means that X minus 3 is going to be between what? 0.5 and a what? Negative. Everybody with me? I can start building from this, but I know that I want to end up with this. Right? Now, what was my epsilon? My epsilon was a what? A 1. I just start building it out. You see what I'm saying? In other words, I'm like, I really need a 2x. Okay, well, how can I turn that into a 2x? I can multiply everything by what? 2. Well, what's that going to be when I multiply that by 2? A what? Oh. That's a 2x minus a what? 6. And that's going to be a multiply by 2 is going to give me a what? A 1. And then I go, for some weird reason, I'm going to write this minus 6 as a plus 1 minus 7. And then, oh, those math, you see what I'm saying? Like I'm starting to go and I'm building it out. Is everybody with me? So that I end up back with what? With this. So that means the absolute value of 2x plus 1 minus 7 is always going to be smaller than what? 1. I'm just doing backwards what I did before. But that hadn't got to work just one time. That's got to work what? Every time. All right, so let's change it. Give me a smaller epsilon. See if I can do that one. Give me a smaller one. I've got to find what? Delta. Everybody with me? Well, I got to start over. Now, I'm supposed to start with this and go to this, but guess what I'm about to do? I'm going to start with this and see if I can get backwards. Everybody with me? So I'm starting with what? The absolute value of f of x minus what? L is less than what? Epsilon. Okay, what's my f of x up here? Remind me. 2x plus 1 minus what's my L? 7. But this time he told me my epsilon wasn't 1, it's what? 0.1. See if we can do it. So I will drop those so I can simplify the middle. What's that going to simplify into? 2x what again? Minus 6, right? Now, how do I get rid of the bars? Well, that means that 2x minus 6 is going to be between what two values? Negative 1/10 and a positive what? 1/10. Now, what am I going to do to get rid of that minus 6? I'm going to 6 all the way across. So that's going to give me 2x is going to be this negative 1/10 what? Plus 6, and that 1/10 what? Plus 6. Now, what's an easier way? What's a negative 1/10 plus 6? That's the same thing as 6 minus what? 1/10. In other words, what is it? 5.9. That's going to be what? 6.1. Now, what have I got to do all the way across? Okay, you got the calculator. What do I get when I take 5.9 and divide by 2? And then when I divide that by 2, I get what? 3 point what? Now, that's got to be C plus delta, and that's got to be what? C what? Minus delta. Now, remind me, what's my C? 3, right? Well, then what is delta? Yeah, I'm always looking for plus because it's easier to do in my head. What do you add to 3 to get 3.05? 0.05. Double check it over here. It's 3 minus 0.05, 2.95.
Why doesn't that prove it?
Because you can't prove something using particular values. In other words, sometimes something works 100 times and then blows up on the 100 what? First time. And it's got to work for every number. And since I can't name every number, I can't check what? Every number. Now, what if you made epsilon 0.01? If I keep doing this, every time you change epsilon, I got to change what? Delta. Now, I'm going to go ahead and tell you, if you do that, you get that. Now, after I do about 10 of those, or 2 of those, or 3 of those, sometimes you get lucky and you see a pattern. What's the pattern? Just divide it by 2. Well, what does that mean then? That means every epsilon you give me, I can find a what? A delta by just doing what? Divided by 2. Now, I don't like working them 9 million times. And sometimes patterns are hard to see. So I'm not going to use numbers. I'm going to do it generally. Then I've only got to work it 1 time. Let's just call myself efficient, not lazy. But now here's the catch. When they do the proofs in the book, they don't show you this scratch work. It looks like the heavens open and Jesus just said, take epsilon and divide by 7. And you're like, how did you know to do that? Everybody with me? So I'm going to show you how I do it generally once, rather than doing it for like 4 or 5 values or 8 or 9 or 10 before I see the pattern. Okay. So here's what I would want you to do if I told you to prove something. Now I'm going to show you the scratch work. Is everybody with me? Then I'm going to show you the proof. But when you understand what Gan's really doing is she's fudging. She's looking at the answer and what? Working backwards. So I'm supposed to start with this and end with this. But what am I going to do on my scratch work? I'm going to start with my what? Answer. So what am I going to start with? I'm going to start with the absolute value of f of x minus L is less than what? Epsilon. Everybody with me? Now, what have I got to end with? I've got to end with what? The absolute value of x minus c is less than what? Delta. So I'm supposed to start with this and end with that, but on my scratch work, I'm starting with the ending and ending with the beginning. Everybody understand how I know what to put first and what to put second? Now, in this particular problem, what's my f of x? 2x plus what? 1. Minus, in this particular problem, what's my L? 7. So does everybody see what I did? I filled in my f of x and my L. Everybody tracking with me? Now, go down to the bottom for a second. You see this x minus c is less than delta. What is c in this particular problem? 33. So here's what I need you to see. I need this absolute value to turn into this one. Legitimately mathematical. What can I do first that's screaming at you? Can you clean that up in? What does it clean up into? Now, I need you to think about this as if you were in court and you were the lawyer. And your jury is not smart. All hypothetical, I'm sure. We're not gonna skip any steps. We're not gonna give the prosecutor, we're not gonna give anybody any wiggle room like I am taking the jury minute step by minute step by minute step, so I don't lose them. Okay? I need this absolute value turn in this estimate. How can I do that? All right, but I can't go dividing an absolute value by numbers. Everybody with me? So I'm gonna have to make sure I'm real careful mathematically here. So I don't break any rules and the theorems are screaming at the people. Do you see that I can factor a 2 out right here? Now, you can't just go backing out of an absolute value unless you got a reason for it. So if you factor a 2 out, what's that gonna leave? It's already looking better, isn't it? Now, there is a theorem in algebra that says this. At some point, you should have learned that theorem. If you got the absolute value of a product, that is the product of those absolute values. So do you see that I have the absolute value of a 2 times the absolute value of that parenthesis? So I'm gonna make sure they understand. That's the absolute value of 2 times the absolute value of x minus 3. I mean, I am leading them little baby step by little baby step. Now, what is the absolute value of a positive 2? It is 2. Everybody okay? Now, can you divide both of these by 2? I'm out of room, so let me write a little bit smaller down here. What happens right here to those 2's? They go out. So I've got the absolute value of x minus 3 is less than what? Everybody okay? Now, remember what went under it? Correct? Well, I can turn this into this if delta is what? Epsilon over 2. The whole point of this is the only way that these 2 sentences are both true. The left sides are going to have to match, and the what? Right sides are going to have to match. So the only way this is going to work is if delta is what? Epsilon over what? 2. Now, I'm not going to erase anything. I'm going to go to that board over there. Right. Now, for test purposes, you don't need to erase all that. But to bedazzle somebody, what? You didn't. Don't show them. Now, what am I supposed to start with? I'm supposed to start with that the absolute value of x minus c is less than what? Delta. Now, what am I supposed to end with? I'm supposed to end with the absolute value of what? F of x minus L is less than what? Epsilon. Are we good? Now, let's fill in what we know. What do we know? We know our C is what? 3. Here's what always happens next. They just suddenly say, choose delta equal to something. And it just magically appears in the book. What do you think I'm going to choose delta to equal? How did I know to pick that instead of 2 epsilon over 7 or epsilon over 8? How did I know to do that? The scratch work told me what to pick. Is everybody with me? So now what does this turn into? This turns into the absolute value of what? X minus 3 is less than what? Now here's the best part. You just copied the thing backwards. So what am I going to do to get rid of that 2? Because I don't need that 2. Are we okay? So I've got 2 times the absolute value of X minus 3 is going to be less than epsilon, don't I? Now, don't you dare skip steps, because if the next thing you do is this, I'm going to have a stroke and fuss at you. You just can't go moving numbers in and outside of absolute value. You're using this, then I need to see what? This. Is it legit to say that 2 and the absolute value of 2 are the same thing? Now you can go and use that rule. That's the absolute value of 2 times what? I'm just copying it what? Now, that's the absolute value of 2x minus what? 6. And then for some bizarre reason, here's a million ways to write a minus 6. But how am I going to choose to write it? Plus 1 what? Minus 7. So even my jury with no brain, blah. But do you see that if you don't know what to choose, the whole thing falls apart? So this is all they show you in the book. These things will magically appear. Now, the proofs can get way more complicated if they're not linear. You have to bound it. I mean, it's real fun. But all you're going to do in here, since it's entry-level calculus, is a linear equation. Everybody okay? So what you're going to do for homework is that it's going to tell you to basically get an estimate of however you want to make a guess, but then you have to do a proof. But your scratch work is always, you start at the end and work to the what? The beginning. And when you do that, you always, your whole goal, that's the reason you always see me write this down first and this down second. I fill in what I know on this and then what I know on this. And my goal is to turn this absolute value into what? That one. But if you skip, if you're missing steps, I'm going to have you missing points. Everybody with me? So you can't say, well, you can't jump from here to here. I'm going to be like, how'd that 2 jump out? Well, I better see what you did. You're assuming that the jury has no brain. So you are baby step by baby step by baby step leading them. Then I don't care, you can even leave this on your paper, but make sure you say that this is my proof. We understand that's not my proof. That's just so I know what to choose delta to what? To equal. So your homework's going to be on Canvas, and here's what's going to happen. You're going to have one of those graphs to do everything to. You know, it's answer questions off the graph. You're going to have a few of these proofs to do. And then next week, we get some limit theorems, so we have to keep doing all that. We get exact answers algebraically. Okay, all right, I will see you next time. Come see me if you need some help.